Alright, so this is the next problem on the review, 5.41. This is from the exponential distribution set of problems. So this reads, the magnitudes of earthquakes recorded in a region of North America can be modeled by an exponential distribution with mean 2.4 as measured on the Richter scale. Find the probabilities that the next earthquake to strike this region will have the following characteristics. So for part A, the characteristics are it will be no more than 2.5 on the Richter scale. So let's see. So let's let our random variable x, let's let this be the random variable denoting what the next earthquake will be on the Richter scale. So next earthquake, what next earthquake is on Richter scale. Right, so we were giving the problem that this is going to be approximately exponentially distributed with mean, which remember our mean for an exponential distribution is going to be theta equal to 2.4. So for an exponential distribution with mean or theta equals to 2.4, this is not correct. This is not correct. Sorry. Right. No, this is correct. Sorry. I got a little confused because there's two parameterizations, so I needed to remember which one this was. But no, this is correct. So for our exponential random variable with mean 2.4, which is equal to theta, we have a probability density function given by little f of x. This is going to be equal to 1 over theta times e to the minus x over theta. And this is for x values that are greater than 0. And then this is going to be 0 otherwise. So for our case, this f of x is going to be equal to 1 over 2.4 times e to the minus x over 2.4. Again, that's for x values greater than 0. So if I just write this, that's kind of implied that when x is not, in this range, it's going to be 0. That's kind of the implication there. So now we want the probability that the next earthquake will be no more than 2.5 on the Richter scale. So what is that? That's the probability that x is going to be no more than 2.4, means less than or equal to 2.4. So this is going to be the integral from negative infinity to 2.4 of f of x dx. Right, so this is one of those problems, if you note, this is going to be exactly the CDF evaluated at 2.4. So if we recall, the CDF for an exponential distribution is going to be 1 minus e to the minus x over theta for x values that are greater than 0. So we could just use that, or we could integrate. So yeah, let's integrate for now because I already have it written down. So in our case, our PDF only takes non-zero values when we're greater than 0. So this is going to become the integral from 0 to 2.4 of 1 over 2.4 times e to the minus x over 2.4. We're integrating with respect to x. So again, this is one of those easy u subs that I'm not actually gonna be technical about and do that out. We know that when we take the derivative of e to something, it's going to be that e to the something, and then we have to multiply by the chain rule. We have to multiply with the derivative of the inside function, right, of this exponent. So let's just write down e to the minus x over 2.4. And I guess we still have this 1 over 2.4. So we want, when we take the derivative of this, to get back to here. And when we take the derivative of this, it's going to be the same thing, multiplied by the derivative of what's inside, and that's going to be minus 1 over 2.4. So what I need to do is I need to multiply this by minus 2.4. So you see when I take the derivative now, I get the same thing. This minus 2.4 comes down and cancels with this. I get back exactly to here. And so this is going to be evaluated from 0 to 2.4. So this 2.4, this 2.4, that's going to cancel out. So I'm going to have minus e to the minus x over 2.4. And this is going to be evaluated from 0 to 2.4. So this is going to be equal to minus, I plug in the top number, so e to the minus 2.4 over 2.4, so e to the minus first, minus, I plug in the bottom number, so that's e to the 0th power, so that's just going to be 1. So this is really going to be, when I distribute the negative sign, remember this is 1, it's going to be 1 minus e to the minus first power. And let's go ahead and calculate that. So this is going to be 1 minus e to the minus first power. So I get that this is approximately equal to 0.63212. So that's good. So that is it for the first part.